In this video, I'll be going over how to divide our complex numbers. So here when dividing, we just have to make sure, guys, that you cannot ever have an imaginary number in the denominator. So like, for example, let's say that we are dividing, let's say let's say we're dividing 4 by 3 plus 2i. We cannot divide this out and then keep that imaginary number here in the denominator. So in order to simplify this and actually be able to divide, we're going to use what is called the conjugate. But what is the conjugate? So the conjugate is, first off, you have to make sure that the complex number is in standard form, where you have a plus bi or a minus bi. So we need to make sure that our complex number is in standard form, because then we have to make sure to change the sign, but only of the imaginary part. Do not change the sign of the real part. So we are only focusing on the imaginary, or in this case, like our b. So here, a plus bi and a minus bi are conjugates of each other. So again, to relate it to numbers, if let's say, so from this previous, I had 3 plus 2i. So if I have 3 plus 2i, then its conjugate would be, keep 3, right? Now minus 2i. So only change the sign of the imaginary part. So here, for example, notice how we're going to write the conjugate of each complex number. Here, we just have -8. Well, -8 is a real number. So do we change the sign of a real number? No. So we leave it as -8. But notice how here we have our imaginary, right? Because I have 25i. So this is imaginary. So the conjugate of 25i would be -25i. So we're only going to change the sign of the imaginary part. And then notice here, right? So again, remember that the complex number has to be in that I plus bi standard form. Notice how here we do, right? So only change the sign of the imaginary. So this is -1 minus 9i. Do nothing with the real part, right? But change the sign of the imaginary. Now notice with the last one, it's not in standard form. So let's rewrite it. So here we would have -6, right? Keep the sign in front here. And then minus 105i. Now change the sign, but only of the imaginary. So see how here we have our imaginary? So -6, but then plus 105i. So you have to know what the conjugate is to change the sign of only the imaginary, because this is how we're going to divide. I'm going to show you guys how are we going to get rid of basically the imaginary number in the denominator. Well, we are going to multiply both the numerator and the denominator by the conjugate of the denominator. Remember, we're focusing on the denominator. But what we do to the denominator, you have to do to the numerator, right? Kind of like an equation. You keep it balanced. So like here, for example, notice in the denominator, we have 1 minus 2i. So this would be, instead of -2i, the conjugate would be 1 plus 2i. And then we're going to multiply that. But again, here, right, we can't just do it to the denominator. We have to do the same thing to the numerator. Then here's why, because notice in that final step that we're going to multiply and then combine those like terms. So here I'm just going to focus on the denominator. So here, just like the other day, we're going to multiply. So I'm going to go ahead and set up the box method, just like how we had when we were multiplying. So 1 and -2i times 1 and +2i. 1 times 1 is 1. -2i times 1, -2i. 2i times 1, 2i. Negative times a positive is now a -4, but I squared, right? Because I times I squared. Then remember, right, you can't leave it with I squared, because I squared is -1. Then multiply by -4, negative times a negative is now a 4. So then here, notice on the diagonal, you have 2 plus -2, which gives you 0, gone. So when we're combining those like terms here, notice how you're just left with 1 plus the 4, which is just 5. So notice in the denominator, what used to be 1 minus 2i, then multiplying by its conjugate, we ended up with 5, a real number. That's why we multiply by the conjugate, because whatever we end up with here in the denominator, there cannot be an imaginary number. So again, you'll know that you do this correctly if there is no imaginary number in the denominator. So like this example here. I just wanted to show y'all that, but then of course we would do the same thing and multiply the numerator, because I'm going to hold off though, so we can now go through some examples. So with these first two, notice again, right? See how we have 4i in the denominator? So we got to get rid of that I, right? We can't have imaginary. So instead of positive 4i, change its sign, right? So it's now going to be negative 4i. But what we do to the denominator, you also have to do to the numerator. So we're going to multiply both by that negative 4i. Then here we go. Well, 3 times negative 4i, negative 12i. And here we have 4 times negative 4, which is negative 16, but I times I, right? So I times I squared. Then again, I squared is always negative 1. Then multiply that now by negative 16. Negative times a negative is a positive 16. Now notice that we can still simplify this, right? Because that's negative 12 over 16. Well, I can divide both, simplify, right, by 4. So this is negative 3/4 I. Then number 2. Here again, right, we have 1 plus I. So let's change the sign, right, but only of the imaginary part. So if it's plus I, that means we're going to multiply its conjugate, which is 1 minus I. But now remember, right, when we multiply to the denominator, you have to multiply to the numerator. Now we're going to go through and solve. Notice how that's 5 times 1 minus I. So we do need to distribute our 5 here. So 5 times 1 is 5, and 5 times negative I, negative 5i. Then now the denominator. Well, notice again, right, we're multiplying our two conjugates, so let's set up our box, right? So I've got 1 plus I, and then 1 and negative I. 1 times 1 is 1. Here we have just 1 I, but 1 times negative I, negative I. Then now I times negative I squared, right? Because that's I times I. And again, notice, right? I squared is negative 1. But notice we have that negative here. So negative times a negative is a positive. So that's now positive 1. And again, notice here what happens to our i's. They go away, right? I minus I, 0. So really you're just left with 1 plus 1. 1 plus 1, which is 2. So there you go. Notice how we ended up with just our real number in the denominator. And I cannot simplify, so we're done here. So go ahead now, try these two on your own. Pause the video and let's see what you get. Let's go ahead now and start this first one here. Remember, right, we're going to multiply by the conjugate of the denominator. So with the denominator, the imaginary is negative 6i, and we need the conjugate, which is positive 6i. What we do to the denominator, we also multiply to our numerator. Now we've just got 5 times 6i, which is 30i. Oops, 30i. And then here in our denominator, we have negative 6i times 6i, negative 36, but because you also have I times I squared. Then again, notice, right, I squared is negative 1. Negative 36 times negative 1, positive 36. Then again, notice that I can divide both of these by a common factor of 6, both of those values. So really you have 5 over 6i. Then number 4. Notice again, right, we're going to multiply, but only by the conjugate of the denominator. So here, if I've got 2 minus I, then its conjugate is going to be 2 plus I. What we do to the denominator, you also do to the numerator. Now we're going to solve here, but notice we are multiplying 3 times 2 plus I. So make sure to distribute that 3. 3 times 2 is 6. 3 times I, 3i. Now we can focus on the denominator. Here we've got our box method. So I've got 2 and negative I and 2, but now positive I. 2 times 2 is 4. 2 times negative I, negative 2i. 2 times I, 2i. Negative I times I, negative I squared. Then now notice I squared is negative 1, but you have this negative here like negative 1. Negative, 2 negatives make a positive. So this ends up being positive 1. Then again, notice with the conjugates, right? The negative 2i plus 2 is 0, cancels out. You're just left with here 4 plus 1. 4 plus 1 is 5. So you can leave this as is, or also you could, for good practice, write this as 6 over 5 plus 3/5 I. So now with question number 5 and 6. Now we're going a little bit more to it. Notice again here in the denominator, we have our value here, our imaginary number in standard form. So let's change the sign of the imaginary part. So here I've got negative 1, but now minus 2i, right? Change the sign of the imaginary. Then that means what we do to the numerator, we need to do to the denominator, we do to the numerator. So negative 1 minus 2i. But notice here now, we do have to set up the box method also now for our numerator. Also notice, when we set up the box method, let's make sure to also put this in standard form. So this is 3 plus 2i. So I've got 3 and positive 2i, then negative 1 and negative 2i. Now we go through and just like before we solve. 3 times negative 1, negative 3. 2i times negative 1, negative 2i. 3 times negative 2i, negative 6i. 2i times negative 2i, negative 4, but I squared because you have I times I. Then again, right, anytime you see I squared, that's negative 1. Negative 4 times negative 1, positive 4. So now we've got positive 4 here. Notice on the diagonal, that is negative 6 minus 2, giving you negative 8i. So now here we've got negative 3 plus 4, right? Combine your like terms, minus our 8i. So here in our numerator, we have 1 from negative 3 plus 4, which is 1, minus 8i. Now we need to solve our denominator. So again, box method. I've got negative 1, positive 2i, times negative 1 and negative 2i. Negative times a negative is a positive 1. 2i times negative 1, negative 2i. Now here, notice, be careful, right? Because that's a negative times a negative. Positive 2i. Then 2i times negative 2i, negative 4i squared. And then again here, notice how we have I squared. So I squared with negative 1 and negative 4 times negative 1, making that positive 4. So again, we've got positive 4 here. Notice now on the diagonal, right? Again, our i's, notice what happens with the conjugates. These 0 cancel out because 2 minus 2 is 0. So really you're just left with 1 plus 4, which is 5. So we can leave it as is, or again, you can practice writing this as 1/5 minus 8/5 I. So now question number 6. Notice now how the denominator is not in standard form. So let's go ahead and rewrite this in standard form. So we still have our 8 plus 3i over, but now standard form. -1, right? Because that's a -1. Keep the sign with the value. -1 plus 2i. Now we go through and identify what is the conjugate of the denominator. So I'm just going to go ahead and cross this out here. So I'm going to focus on up here with our standard form. So the conjugate is, again, change the sign of the imaginary. So now here we've got -1 still, right? But now minus 2i. So -1 minus 2i. Now we're going to go through and solve. So let's focus on the top first, our numerator. Here again, set up box method. I've got 8 plus 3i times -1 minus 2i. Now we go through and fill in. 8 times -1, -8. 3i times -1, -3i. 8 times -2i, -16i. Then 3i times -2i, -6, but I squared. Then again, we have I squared. Remember, I squared is always -1. But now we're multiplying that by a -6. Negative times a negative is a +6. So now we've got +6 here. Then again, we have our imaginary. -6 minus 3, -19i. So now when we write this out, I've got my like terms to combine, which are -8 and 6, so -8 plus 6, but don't forget your imaginary, so minus 19i. -8 plus 6, -2, minus 19i. Now let's do the denominator. Same thing with our conjugates. The -1 plus 2i and -1 minus 2i. Same thing, we're going to go through and solve. Negative times a negative, +1. 2i times -1, -2i. Negative times a negative is now a positive 2i. See, there you go again, right? The i's are going to cancel out. And then 2i times -2i, -4i squared. Then again, I squared. So with that I squared, instead of -4, now we're going to have +4. Then same thing, the i's cancel out because -2 plus 2 is just 0. So again, we're left with 1 plus 4, which is 5. So again, multiplying by the conjugate, but make sure that your denominator is in standard form. Then if you want to continue and practice writing your answer, you could also write this as -2/5 minus 19/5 I. So now go ahead and pause the video and try these two U-tries on your own. Now let's go over number 7. Here, our denominator is in standard form, so we're good to go with that. So we're going to multiply by its conjugate, change the sign of only the imaginary. So 2 minus 2i. Multiply that also to the numerator. Here we go. Let's focus on the numerator and set up the box. You should have done that. So 3 positive 2i times 2 and -2i. So here, 3 times 2 is 6. 2i times 2 is 4i. 3 times -2i, -6i. And 2i times -2i, -4i squared. And here again, notice how we have I squared. I squared, -1. Negative times a negative is a +4 is what you should have gotten here. Then we do have like terms to combine, right? We have our two imaginary parts. -6 plus 4 is -2, so -2i. So now with our like terms, I've got 6 plus 4, but then don't forget your imaginary part, so -2i, minus 2i. 6 plus 4 is 10. So 10 minus 2i. That's what we have for our numerator. Now let's get the value that's going to be in the denominator. 2 times positive 2i and 2 and -2i. So again, 2 times 2 is 4. 2 times 2i, 4i. 2 times negative 2i, negative 4i. 2i times negative 2, negative 4i squared. Then here, I squared is negative 1. Negative 4 times negative 1, positive 4. So now we cancel that out. And again, notice, right, what happens to our imaginary? There's just 0, because that's just 4 minus 4. 0, gone. Now I've got 4 plus 4. 4 plus 4 is 8. Now we can simplify this, because see how every value is divisible by 2. I could also look at this as I've got 10 over 8, right, minus 2 over 8i. So if it helps you to separate them to see how they can be simplified. See how with 10 over 8, they're both even. So this is the same as 5 over 4. Divide both by 2. Then minus, same thing here, 2 over 8 is 1/4, so negative 1/4 I. Number 8. You should have noticed that the denominator was not in standard form. So I'm going to just rewrite our numerator, negative 4 plus 3i, but now rewrite the denominator. So this is negative 5 plus 2i. So again, a positive 2i here. Now I can go through and solve. So I'm just going to cross this out because I rewrote it. You had to multiply by the conjugate, which changed the sign of the imaginary. So negative 5 still, but minus 2i. Negative 5 minus 2i as well to the numerator. Now let's set up the box for the numerator. Negative 4 times 3i and negative 5 and negative 2i. So now negative times a negative is a positive 20. 3i times negative 5, negative 15i. Negative times a negative is a positive 8. 3i times negative 2i, negative 6, but I squared, because again, you have I times I. The moment you guys see I squared, right, that represents negative 1. Bring down, multiply still by negative 6. Negative times a negative is a positive 6. So we're going to replace that with positive 6. We have our like terms, our two imaginary parts to combine. Negative 15 plus 8, negative 7i. Now let's combine all of our like terms here. So I've got 20 plus 6, but then don't forget the imaginary, so minus 7i. 20 plus 6 is 26. So 26 minus 7i. So that's what we have now for our numerator. Now let's go ahead and multiply our conjugates and see what value you should have gotten in the denominator. So negative 5 plus 2i and negative 5 minus 2i. Negative times a negative, positive 25. Negative 5 times 2i, negative 10i. Now notice here, negative times a negative is a positive 10i. Then positive 2i times negative 2i, negative 4, but I squared. Then here, I squared is always negative 1. Multiply that now by negative 4. Negative times a negative is a positive 4. So now we've got positive 4. Notice here again, right, what happens to our i's? 10 minus 10, 0. So they canceled out. You just have 25 plus 4, making that value in the denominator 29. Then, of course, you can practice writing it as 26 over 29 minus 7 over 29i. And with this last you try, let's see how you did. We're using this expression here, 9i divided by negative 2 plus 7i. What is the conjugate of the denominator? So again, you're only changing the sign of the imaginary. So that means that's why the answer is B, negative 2 minus 7i, right? So you keep the real part, change the imaginary. What is the quotient? So quotient, remember, right? That's just, again, our term for dividing, the answer to a division problem. So that just means, what is the quotient? All we're doing is taking that we have 9i And we're going to divide that by negative 2 plus 7i. But in order to do that, right, we have to multiply by the conjugate, which is negative 2 minus 7i, then negative 2 minus 7i. Now let's focus on the numerator. Notice how we're distributing a 9i. So 9i times negative 2 minus 7i here. So 9i times negative 2, 9i times negative 2 is negative 18i. Then 9i times negative 7i, right? Because that gives us negative 18i. So 9i times negative 7i, negative 63i squared. Then again, I squared is negative 1. See how now this is a negative 63. So bring down and multiply by negative 63. Negative times a negative is a positive 63. So that's how you get negative 18i plus 63. Now let's set up the box for our conjugates in the denominator. Let's see what value you get. Negative 2 and positive 7i and negative 2 and negative 7i. Negative times a negative is a positive 4. 7i times negative 2, negative 14i. Negative times a negative again, positive 14i. 7i times negative 7i, negative 49, but I squared. Then here again, I squared is negative 1. But we're going to multiply that by negative 49. Negative times a negative is a positive 49. So now we've got positive 49. Then again, what happens to our i's here? 14 minus 14, 0, gone. So really you just have 4 plus that 49 here, giving you that value in the denominator of 53. Now I just realized, and I apologize, that our numerator was not in standard form, right? So let's also rewrite our final answer, but in standard form. So this now needs to be 63 minus 18i over 53. Now, so it's asking, what is the real part and what is the imaginary? So that's why we split apart our answer into those two fractions. So the real part would be 63 over 53. So then the imaginary would be not 18, right? But negative 18 over 53i.